Hello, today we'll be looking at reactions involving amides, amines, and nitriles. And today we're going to be going over some common reactions that you can find in the Year 12 Chemistry Syllabus with these three compounds. So with all the compounds that we've gone through so far, with the amines, they also have a primary, secondary, and tertiary amine. Whereas with the other compounds, such as when we went through haloalkanes or alcohols, for example, you had the central carbon, and then the amount of alkyl groups was a reflection of whether it was a primary, secondary, or tertiary compound. With the amines and these nitrogenous compounds, it's actually the central nitrogen, and then the groups that are bonded to it that kind of reflect if it's a primary, secondary, and tertiary amine in this case. So with ammonia, ammonia is nitrogen, so the central nitrogen, with 3 hydrogens bonded. So recall that hydrogen can make up to 3 bonds, up to 3 covalent bonds, that is. If it has 3 hydrogens bonded and no alkyl groups, we call it ammonia. If it has one of the alkyl groups and 2 hydrogens, we call it a primary amine. If it has 2 alkyl groups and 1 hydrogen, we call it a secondary amine, and a tertiary amine only has alkyl groups bonded. So in the video on naming, we had a brief discussion on naming some primary amines. So you may recall that we had the amine functional group, and then we had a chain of an alkyl chain of unknown length. So for example, if our alkyl chain was 2 carbons long, so say this alkyl chain was 2 carbons long, that the name would obviously be ethylamine, right? But that's primary amines. So what do we do in the case where we have, say, a secondary or a tertiary amine? It is quite rare that you'll be asked to name a secondary or tertiary amine in an exam setting, but it is important that we have a discussion on it. Typically, with the secondary and tertiary amines in an exam scenario, they will have the same length of functional group, and that's why I've said R2 and R2 instead of say R1 and R2, signifying 2 different chains. And for the tertiary amine, I've said R3, R3, and R3. So in this case, you're going to use your mono, di, tri, tetra prefixes. For example, we'll start with the secondary amine. I'll clear the board here. We'll start with the secondary amine. Say each of these R2 groups was 2 carbons long. So this is 2 carbons long and this is 2 carbons long. We would call this compound diethyl amine. So basically 2 ethyl groups and an amine functional group. Same case here. So if there were 2 carbons long, it would be triethyl amine. And that should take you for most of the cases in an exam scenario. However, there are some exceptional cases where your teachers might be really tricky and give you a scenario where maybe this R group and that R group are of different lengths, right? So maybe this one is of 3 lengths and this is of 2 lengths, right? What do you do in that case? What you do is you name the compound as if it were a primary amine to start off with. So it has a 3 carbon alkyl group, an alkyl group of 3 carbons long, and it has this kind of amine functional group. It's not really an amine functional group because, as we know, an amine functional group is NH2. Let's just say it is for now. So we have forgot propanamine, sorry. Now what we're going to do is name this functional group here. So we're going to stick an N dash and then the prefix for however long that functional group is. So it's 2 carbons long, so we call it an ethyl. So this is N-ethyl propanamine. I'll go through another example here. So say this was 5 long and this is 1 long. Again, we name the longest chain first. So this would be forgot how to spell today actually. And that would be N-methyl pentanamine. So this is pentanamine, and then we have an N-methyl group attached to it. And you can think of the N representing this nitrogen. So there's an extra nitrogen, there's an extra methyl group tagged onto this nitrogen, but the entire compound is pentanamine. That's also the case with the tertiary amines. So you start with the biggest chain. So we'll go through another case example. So say this has 5 chains, this has 2 chains, and this has 1 chain. We name the compound with the largest chain. So pentanamine. Pretend that's an N. So pentanamine. Now we have 2 groups. So what are we going to do? Recall that all the prefixes need to be in alphabetical order. So this is an ethyl group, and this is a methyl group. Obviously, E becomes in the alphabet before M. So this is an N-ethyl N-methyl pentanamine. So that's what you do if they're of differing lengths. So you utilize your N dash and then your prefixes. However, you're always naming it in terms of the biggest chain length. So we'll now go over some of the reactions that amines can participate in. In your mind, you can categorize them as amines reacting with inorganic acids and organic acids. So we'll start with the inorganic acids first. You may recall that inorganic acids are acids that are non-carbon based. So that could be your hydrochloric acid, your sulfuric acid, and your nitric acid, for example. So when these amines or ammonia, it's important to say, when amines or ammonia react with these inorganic acids, it's important to know that amines and ammonia are weak bases. So they'll act as kind of, this reaction will kind of proceed as just a normal acid-base neutralization reaction, right? We went over some of these in the videos on pH, so look over the chemistry of those if you're unsure, but just to tick off the syllabus dot points, so amines can react with inorganic acids to give you the amine salt as a product. That's the main takeaway from these reactions. So we have an example here. We have methylamine reacting with hydrochloric acid to give you this amine salt. And you can see that the hydrogen has just added to the amine functional group, and so is the chlorine, and you get this nice amine salt. I've got another diagram illustrating this concept of how the amine can react, if a primary, secondary, and tertiary amine, can react with hydrochloric acid. And it's important to state that you can either get a primary, secondary, and tertiary amine salt. So that doesn't really matter for whichever acid you have. So if you have, for example, nitric acid, the only thing that would change is you would still have the hydrogen added across all of these amines. So you'd still have the NH part, but the only thing that would change is instead of the chloride, you'd have this NO3 minus. So that's the main important takeaway. So just know how to write these amine salts or the formula for these amine salts, or rather understand what's actually going on. Amines can also react with organic acids, and the main organic acids that we're going to focus on is your carboxylic acids. You can compare this reaction to being very similar to your carboxylic acids and your alcohols reacting to give you an ester. However, in this case, your amines or primary amines are going to react with your carboxylic acids to give you your amides. So I'll show you this reaction in a little more detail here. So essentially very similar to the reactions of carboxylic acids and alcohols, the amine group and the carboxylic group, the OH part of the carboxylic group kind of combine in the right geometry. The H and the OH kind of leave as water, and thus you get a nice amide linkage of the nitrogen bonding here, and that is where this comes into play. So you can see that this is essentially the combination of both of those compounds combining together with water as a leaving group, and that's exactly what happens here. And I've got a nice general formula for you to use in the exams if you want, R1 being the alkyl group of the amine, R2 being the alkyl group of the carboxylic acid, and notice how you have the amide functional group, and on either side you have the alkyl groups contributing from the amine and the amide. And don't forget water as the leaving group. So before we have a conversation on reactions involving amides, it's important we start with primary substituted and disubstituted amides. So this mirrors primary, secondary, and tertiary compounds. However, it's slightly different with the amides. So like all of the compounds, you have your primary amide, which is your amide functional group with just one alkyl group bonded. you have a substituted amine. So if we look at nitrogen in the primary amide, nitrogen, as you can recall, can form up to 3 bonds. So we have 1 bond here and 2 hydrogens that are bonded, giving us a total of 3 bonds. In the substituted amide, one of those arms in nitrogen, or one of those bonds in nitrogen, is used to form a bond with another alkyl group. So you have your original alkyl group and you have another alkyl group bonded with nitrogen. In your di-substituted amide, so di meaning 2 groups bonded to nitrogen, you have your original alkyl group from the primary, you have another group from the secondary, and now you have a tertiary or a third group bonded to this nitrogen. And notice how nitrogen is no longer bonded to any hydrogen molecules. So very similar to the video on naming, we went through a very brief example on naming primary amides, and that should cover you for most of your bases in Year 12 chemistry. So you have your alkyl group here, and say that's of 6 carbons length, right? When naming this, you use the hex prefix to signify that it has an alkyl group of 6 carbons length, and then you use the suffix anamide to signify that it's an amide. And that naming primary amide should be most of the question that you get in regards to naming these type of compounds. It is very rare that you get asked to name a substituted and especially a di-substituted amide, but it's important that we go over some of these examples. So with naming these compounds, you always name it not the longest chain that you named it in regards to the amine. You always name it based on the alkyl group on the C double bond O side of the amine functional group. So it's going to be R1 in both these cases. So we'll go over a brief example here. So say this is 5 carbons long, and this functional group here, I'll draw a better arrow, that's 2 carbons long. So we look at the compound. So we're going to first look at the alkyl group on the C double bond O side of the amine functional group, and that's 5 carbons long. So that's going to be pentanamide. And then we're going to utilize our N-terminus nomenclature, right? So there's a N-ethyl group, N-ethyl group attached to this pentanamide, right? So we name it N-ethyl pentanamide. And remember that N, you can use it as a memory tool. That N dash signifies whichever group is attached to the nitrogen, right? This is quite similar to what happens with the di-substituted amides. So say this is 5 carbons long, this is 2 carbons long, and this is 1 carbon long. So we always name it based on the alkyl group that is closest to the C double bond O side of the bond, the amide functional group, that is. So in this case, it's an alkyl group with 5 carbons long, or this one. So it's a pentanamide. Now we have 2 alkyl groups bonded to the nitrogen. One of them is an ethyl group, and one of them is a methyl group. We need to organize these in terms of our N-terminus nomenclature, as well as making sure that they're in the correct alphabetical order, as in the example that I went through in the amine, naming the amine tertiary amines, that is. So E obviously comes in the alphabet before M, so this is an N-ethyl N-methyl pentanamide. And that's kind of what we're saying down here. So the primary alkyl group is in red, and that's on the C double bond O side, and that's essentially what you use as the building blocks to naming it. And every other alkyl group, you stick an N dash and then the prefix of that alkyl group, but signifying how long it is, and then you latch on the rest of the name. I've just got 2 more worked examples to hammer this point home. So on the left hand side, we have a substituted amide. So I'll isolate the functional group for you here, and then we'll analyze it. So the alkyl group on the C double bond O side is 1 to 3 carbons long. So that's the prefix but. The other substituted alkyl group is 1 carbon long. That's this one. So that's methyl, or butyl if you like. Next, we name it based on this alkyl group here. So that's butyramide. However, there's an N-methyl group attached to this butyramide, right? Same thing on the right hand side. However, this is a di-substituted amide. So if you look at this, there's two alkyl groups bonded to this nitrogen, and I've isolated the functional group again for you. We name it based on the alkyl group that is on the C-1O side. However, there's two methyl groups bonded to this nitrogen. So this is a N, N-dimethyl butyramide. You can also write it like this, no problem. N-methyl. N-methyl. And if you're unsure in an exam setting, don't risk it. Just write it like this. They can't technically penalize you because it is right. However, this is the official name for it. You're likely to get more marks for it that way. So you can think of the amine and amide reactions, especially with organic acids, mirroring those, like I said, between an alcohol and carboxylic acids. So amines and carboxylic acids combine to form amides, and that usually happens in reflux, very similar to the reactions between carboxylic acids and alcohols that also requires reflux. Conversely, you can have a hydrolysis reaction, right? Where you break apart the amide, in this case, into its corresponding amines and carboxylic acid. So essentially you're doing the reverse as a reaction between these two, right? This requires a couple of things. You usually need concentrated sulfuric acid, so don't forget to write that. Sulfuric acid is a dehydrating agent and a catalyst in this case. And you also need a high temperature, so lots of heat. And this is a general formula for this reaction. So notice that you have the amide functional group, you have alkyl groups on either side. Under the presence of sulfuric acid and heat, you get the amine on one side, and you get the carboxylic acid on the other. So obviously, when you break it apart, you're essentially breaking apart this bond. This side, whatever alkyl group is on this side of the amide, is the alkyl group on that side of the amine, and whatever alkyl group is on that side, or the C-O side of the amide functional group, forms your newly found carboxylic acid. So that's just the most important thing to remember. Now we'll go over some of the reactions involving nitriles. Look, it's not really typical that you'll be examined on these, but in the way of review, in the covering of all your bases, it's important that we cover these. So recall that nitriles are signified by this functional group. So you have carbon triple bonded to a nitrogen. You can only really get primary nitriles, so that's another less thing to worry about. You can't get secondary or tertiary nitriles. Obviously, if you could, they wouldn't be nitriles because you need that triple bonded carbon to nitrogen. The most important reaction of the nitriles that you're likely to come across is a hydrogenation reaction. So you have hydrogen gas pumped in to the nitrile with a platinum catalyst, and what they form is a primary amine. So that's just the most important thing to remember. You're kind of splitting apart that triple bond and forming an NH2, and that's your primary amine. So the last reaction we're going to go over is acidic and alkaline hydrolysis reactions of nitriles. It's very rare that you're going to come across these in your year 12 exams. If you do get a reaction on nitriles, it's probably going to be your hydrogenation reaction. However, we will cover these reactions just to cover all our bases in the case that your teachers want to trip you up. So nitriles heated by reflux in a strong acidic condition, and that usually involves an inorganic acid such as hydrochloric, nitric on sulfuric acid will give you carboxylic acid. So that's just another way you can form carboxylic acids. With all these reactions, especially in chemistry, it's important to know that you're not just memorizing reactions, rather look at what you're making and think of how you're making it. So with the carboxylic acid, you can make it via nitriles, reflux, and acidic conditions, or you can also hydrolyze an amide, right? That you can get a carboxylic acid that way as well. So it's important to look at these reactions in that type of way and not just strictly just memorizing them. However, with nitriles, if heated under reflux in acidic conditions, that is, you'll get a carboxylic acid with the chain being however long the chain is in the original nitrile. So we have a just a methyl nitrile here. Thus, you get methanoic acid. It's important to also understand that you get ammonium salt, an ammonium salt as a byproduct. And that'll differ, the salt will differ based on what acid you use. So in this case, we use hydrochloric acid. However, if you use nitric acid, that salt would obviously be NH4NO3. If these nitriles are heated under reflux, not in an acidic condition, in a basic condition, so usually this will be your sodium hydroxide, lithium hydroxide, and so on and so forth, you'll get a carboxylate salt. And you may remember your carboxylate salts. That is what happens when alcohols actually react under strong basic conditions. So you essentially get your nitrile reacting with your strong base, and you get this carboxylate salt once again. And you might want to go back onto our video involving alcohols where we dilly-dally over saponification and carboxylate salts, and that's another way that you can actually make a soap, right? Using this nitrile reaction. However, instead of the ammonium salt, you just get ammonia. And also remember that the carboxylate salt will be of whatever length the original nitrile is. So if you have ethyl nitrile, you get an ethanoate salt. So that concludes our last video on this series on common compounds and their reactions that you're going to be finding in Year 12 Chemistry. We'll have another video going over some exam questions that you can expect, because it's important that you don't just strictly learn linearly. So not just memorizing these reactions, but also learning how to apply them in an exam setting with exam questions. I also recommend, as well as watching the next video, that you also supplement your learning with some flashcards and multiple choice questions, because it is a lot of content to remember. However, if you just do the flashcards daily, I'm sure you can all get on top of the content.